So the first concept we're going to look under this topic is that of work. Now let's say we have a body and we apply a force F, a displacement D happens. Right? Once a displacement happens, of D happens, we say work is done. How do we calculate the work? We calculate work by multiplying the magnitude of F force into distance or displacement, into the magnitude of displacement. This is the most simple way of calculating work, right? Now let's take another case where there is a body, a force is applied in this direction and a displacement D happens, right? That means there is an angle theta between the force and the displacement. In such a case, we calculate the force by first multiplying the component of force in the direction of displacement. That is F cos theta into D, right? In other words, if you look, this is the dot product between force and displacement, right? And I'm going to write this as S so that later the displacement I'm going to represent it as S, okay? So it'll be easy. Work is equal to the dot product between the vector of force and displacement. So as we know that the dot product is a scalar quantity, the work can be positive, it can be negative, and it can be zero. When is it positive? When we look at here, the force is applied, the displacement happens in the forward direction. That is, when the force and the displacement are in the same direction, work done is positive, right? So let's say I drop this pen to the ground, gravitational force is acting on it, and the displacement is also downward. Both are in the same direction. The work done by the gravitational force is positive, right? Now let's look at negative. Let's take a case where a body is moving in this direction, a forward direction, and friction is acting in the opposite direction, right? In this case, if we take the dot product, okay, of friction and displacement, we're going to get a cos 180. Therefore, this is going to be minus Fd, right? Or the friction force, magnitude of friction force into displacement, the minus of it. The work is going to be negative. That is, when the force and the displacement are in opposite direction, then the work is said to be negative, right? Let's take the case of zero. Now, this is a very interesting case. Let's say I would hold a body in my hand, with my hand. I'm applying a force upward, but the body is at rest. The displacement is zero. In this case, the work that I am doing is zero. Now, I may tire down holding it this way, but the fact is, in physics, the work that I do is F dot D. And in this case, D is zero. That means the work that I am doing is zero. When there is no displacement, there is no work done, right? Now, there's another interesting case that you can see, which I would like to bear. Okay, now let's say we know that work is equal to F dot S, okay? And let's say in the centripetal motion, a circle, right? A body undergoes a circular motion and there's a centripetal force, right, acting. Now, when we look at the centripetal force, right, the displacement acts along the tangent and the force is perpendicular to the displacement. Therefore, if we do F is equal to, and let's say this is the force F, we are doing F dot S, we find that it becomes F into S cos 90. Because the direction between the force and the displacement is 90. So this is equal to 0. So this is another interesting case where the force and the displacement are perpendicular to each other, then the work done will be 0, right? Now, when we did F dot S, we assume that the force here is a constant. Now, what happens if there is a variable force, right? The force keeps changing and there is a displacement. So work is done. So in this case, we resort to integration calculus is what helps us here. We take it for an infinitesimal distance ds. You can assume the force to be constant, right? So for that, dw will be equal to f dot ds, right? For very short infinitesimal distance ds, the force you can say is constant, right? Therefore, the total work will be equal to, you integrate f dot ds, okay? So you're integrating along the whole path of displacement where the force is changing, and the value of integral f dot ds will give you the total work that is done.